The figure illustrates medicine wheel, a Native American structure in northern Wyoming. There are 27 Aboriginal spokes in the wheel, all equally spaced. Find the measure of each central angle in degrees and in radians in terms of pi. All right, so if you draw equally spaced lines, you can do this yourself. So, let's just, so 1, 2, 3, 4, 5. So I just drew 10 lines. So drawing 10 lines, what does that correspond to in terms of either these sectors here? It's going to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if you made 27 equally spaced lines, there's going to be 27 sectors. Okay, so what we're doing is we want to divide full rotations into 27 pieces. So, okay, in degrees, we've got 360 divided by 27, and in radians, we've got 2 pi divided by 27. So in radians, it's 2 pi over 27. They wanted us to leave it in terms of pi. In degrees, it's, so 360 divided by 3 is 360 divided by 27 is 40 over 3 degrees. Which, well, we could convert that to, okay, 40 over 3. So 13 1/3 degrees. Okay, if the radius of the wheel is 76 feet, find the circumference. Well, that's easy. 2 pi r. It's almost like a trick question. It's too easy. 2 pi 76 feet. So the circumference is going to be in feet. $478. Find the length of each arc intersected by consecutive pairs of spokes. So I guess they're just asking for each, oh yeah, consecutive pairs of spokes. So like this arc length. That's going to be the arc length intercepted by a radian measure of 2, or either one of these, but we're going to use radians because it makes arc length easier to calculate, and a radius of 76 feet. So S is equal to theta r. We're going to use, this is in radians, so two times pi over 27 times 76, but 17.7 feet. Okay, find the area of each sector formed by consecutive spokes. So like an area, this area. Well, what's the area of a sector? You should be able to derive the area of a sector from scratch whenever. It's easy. The formula is a little bit simpler with radians, but the idea is, so let's do it in radians. What's the area of a full circle? Well, that's pi r squared. Okay, now it's just what's the fraction of rotation of the sector compared to the full rotation around a circle? So, well, it's whatever theta is, right? Whatever, that's the rotation. It just depends on the angle. That's divided by 2 pi. Now, with radians, this simplifies. With degrees, this would be 360, which wouldn't simplify, but with radians, it does, because the pi's cancel. So you've got 1/2 theta r squared. That's the area of a sector. Okay, so we're in radians, so we know that the angle in each of the sectors is, in radians, it's 2 pi over 27. And then the radius is 76. And that's feet. So we're going to get an area in square feet. So, okay. 2 pi over 27 divided by 2 is pi over 27 times 76 squared. About 672 square feet.